Hi class, this is Mr. Morris. I'm making an instructional video on changes of matter. So you want to follow along with this, make sure that you're filling in blanks, taking notes, and pausing the video when I tell you to pause it in order to do a little bit of practice or application. So make sure that you update your table of contents. These are changes of matter. That's what you should put in the title. You should put in your table of contents. And then go ahead and number your notes right here. Do make sure that you put your name at the top. Remember, that will be part of your binder check grade. At this point, I'm going to go ahead and get out of the way and let you focus on the notes. All right, a physical change. Well, a physical change is really just something. It's a change which only alters a substance's physical appearance. Now, it may also affect some of the other properties, some of the other physical properties, but the key is it does not change its identity. It does not change the chemical composition. So that's the important thing to recognize. This is a change of physical appearance that does not change the chemical composition. There's lots of examples you could probably think of. We talked about some of them already. Some physical changes that you may experience, and you may have heard about this in middle school even, would be things like ripping or tearing, or if you were to boil something. Also, if you were to cut something, that is a physical change. Break. Let's make some more down here. Maybe freeze. Dissolve. I want you to put a star or something to take note of this one. It's a little bit harder to remember. That's one that a lot of students get hung up on. Dissolving is actually a physical change. It's not a reaction. It's just rearranging in a different way. So dissolving is actually a physical change. If you were to melt something, that's a physical change. Or condense. Or crush. And you may be able to think of lots of other examples, but those are some of them. I'm going to circle in red the ones that are a change in the state of matter, because right down here we're talking about the ones that correspond to phase changes. Okay, phase changes or changes of the state of matter. The phase changes are boiling, freezing, melting, and condensing. Now, we are changing some of the physical properties when we do this, but we are not changing the chemical composition. That's what makes these physical changes, because it happens without changing the actual identity of what the substance is. If we were to look at a molecule or an atom, it would still be the same thing. It's just in a different state of matter. So let's talk about these phase changes. What are they? What's a phase change? Well, as temperature and pressure. So sometimes it can actually happen with pressure. Don't forget, temperature and pressure change. As temperature and pressure change, most substances undergo a phase change. Phase change is a change in the state of matter. You may want to highlight this and just make sure that you take note of it. A phase change means it's a change of the state of matter. So we've got a few different changes of state of matter. What would you call it if we're changing solid into liquid? I hope you identified that as melting. So if we were to change solid into liquid, that would be melting. What about liquid to solid? Freezing. Liquid to gas. There's a couple possibilities with this one. One is boiling. The other word for it is evaporating, depending on what type of phase change we're dealing with. Both are changing from liquid to gas. What about gas to liquid? Gas to liquid is called condensation or condensing. Condensing, or you could say condensation. These two are a little bit different. You're not probably as familiar with these. It's a little bit harder to know. From solid to gas, that's like if you've ever seen dry ice. Dry ice sitting out at room temperature, it almost looks like it's smoking. What's happening is it's changing straight from the solid state of matter into the gas state of matter. It skips liquid completely. That solid to gas is called sublimation. Sublimation. You need to know that word. That's a new vocab term for you. Going from a gas to a solid is called deposition. Deposition. Okay, and all of these are phase changes. All of these down here are phase changes, and everything we've talked about so far, we're not changing the chemical composition, so this is a physical change. But if we go down to just the next section of these notes, it talks about chemical change. So let's look at those for just a little bit. Okay, a chemical change is a process that involves one or more substances changing into new substances. Okay, these are new substances. There has to be some sort of transformation going into a different type of substance. Okay, also known as chemical reaction. So you see chemical change, another word is reaction. Know that word, that's a big deal. Okay, chemical reaction is the same thing as chemical change. Chemical bonds, if we're dealing with a chemical reaction, that means that chemical bonds are either formed or broken. They're either formed and or broken. We'll talk more about what that means later. But you've probably all seen what water looks like. It's H2O. It's held together by these bonds. The hydrogen and the other hydrogen and oxygen, they're all held together by chemical bonds. A chemical reaction would mean that some of those bonds were broken and it was rearranged in a different way. Let's talk about some examples of chemical change. These are, some of you might remember these. Some examples would be burning, rusting, baking, cooking. I guess we're kind of repeating ourselves here. Cooking if it is baking. Okay. Maybe exploding, which is a type of combustion. Exploding. Growing. If we're talking about plants or animals, they can only grow by chemical change. That's not a physical change. They can only grow because of the chemical reactions that are taking place inside of them. Okay, and then finally, color change. Be careful with this one, because it's not always true that it's a chemical change. Okay, color change is a good indicator of chemical change. But if something changes colors just because of the way that it's mixing, like yellow and blue mixed together to make green, that's a physical change. They're just mixing. But let's say we're pouring two different solutions together and it makes a new color that is not just the result of those two colors being blended together physically. That might be a chemical reaction that made some new substance that has a different color. Okay, pause the video for a little bit and see if you can check your understanding of this. Label it as P or C based on the type of change that it is, physical or chemical change. All right, so let's check our work. Physical or chemical change. When gasoline burns, the temperature increases. Now, temperature increasing, that's actually could just be a physical change, but we got to look at why the temperature is changing. Why did the temperature increase? Because gasoline burned, and if gasoline burns, we're talking about a chemical change. When temperature is increased, iodine crystals sublimate. An iodine crystal sublimates. Okay, it sounds to me like we're talking about sublimation. And sublimation, even though it's something we're less familiar with, it's still just a phase change, which makes it a physical change. Yellow ink and red ink are mixed to produce an orange color or an orange solution. Now, we all know if we mix red and yellow, it's going to make orange. It's just what happens when you mix them. So that's not anything unusual happening. So I would say this is probably a physical change. It doesn't sound like any reactions are happening. It's just mixing. Okay? When a yellow solution is mixed with a red solution, a brown solution is produced. Now this one's a little bit tricky, but yellow and red don't necessarily make brown. So if we mix yellow and red and it makes brown, there's probably a chemical reaction that's taking place. So I would put a C here. As water boils, bubbles appear. Now sometimes if you see bubbles, that could be an indication that there's some chemical reaction taking place, chemical change. But it tells us that this is as water boils, as water boils. I guess we should be circling these because they're actually vocab terms. I'm sorry. Let's go back. As water boils, bubbles appear. And it doesn't matter if it's water. If something's boiling, what kind of change is that? It's physical. Now it says when vinegar is mixed with baking soda, bubbles are formed. Now this, vinegar is a liquid, baking soda is a solid. If you mix them together and bubbles are formed, that tells me we've got some sort of reaction taking place. So that is indeed a chemical change, a chemical reaction. All right. Now, as you've gone through these notes, I hope that it helped you to understand the differences between physical and chemical change. Physical change, there is no change to the chemical composition. It's still the same substance. It might be a different state of matter. It might be a different appearance. But there's no change to what it is, what its chemical identity or composition is. And chemical change, on the other hand, involves changing one or more substances into new substances. That's some form of chemical reaction. Great examples are rusting, burning, any type of cooking. And color change can be a good indicator of that, especially if it's something that's not immediately apparent that it would be natural. So I hope these notes were helpful. I hope it gives you a good boost in the right direction. I want you to spend a little bit of time now going through the worksheet and trying to identify whether the changes are chemical or physical.